This is the second video in our series on algebraic numbers. So in the last video we said a number A, we defined A to be algebraic, A element of the complex numbers, to be algebraic if and only if there is a polynomial in the rational numbers with p of alpha is equal to 0. So this is definition of A being algebraic. What do you call it? Alpha algebraic. Okay, so this is definition. Let me just put definition. So we have an element in the complex numbers is algebraic if there is a rational polynomial with where alpha is the root. So let's have an example of this. So for example, we have the square root of 3 is algebraic. In fact, before we look at that, let's have a look at is 2 algebraic? Yes, it is algebraic. For example, we can write 2. So this is it as a number, and we can find a polynomial. So we can find x minus 2 is equal to 0. So where 2 is the root of this polynomial. So this isn't the only polynomial you can use. For example, you could have maybe 4 times this. You can have 4x minus 2 equals 0. And this is also, you can expand it out and check it that it's of the form some rational number. And then, so a polynomial in the rationals. And instead of 4, maybe you could, if you wanted to make it into fractions, you can do this, and then it would be 1/2 x minus 1 equals 0. This would also have 2 as a root, and in this case you can clearly see that this part can be a rational number, and this can also be a rational number. What we can't have, for example, is x or maybe, for example, if we're looking at another example of square root of 2, this is algebraic, but you can't say it's algebraic because x minus square root of 2 is equal to 0, because square root of 2 is not rational, so this is not a rational polynomial. But it is algebraic because what you can do is you can say x squared minus 2 equal to 0 has square root of 2 as a root. You can check that by the definition of square root of 2. If you square it, you get 2. Actually, that's something pretty funny. You might not think that needs explanation, but some people just see square root of 2, just sees a thing, but they're not sure what properties it has. So the only property you need to really care about is that when you square it, you get 2. That's the only thing. And the same with I. So if you understand square root of 2, you also understand I, because it works the same way. The only thing you need to know is that if you square it, you get -1. Okay. So that's an algebraic number, and we've just seen so we've seen 2, and we've seen square root of 2. But the thing is, we can do even better. For example, we can say that if q is a rational number, then q is also algebraic, right? Q is algebraic. And okay, you can write it different way. Maybe more mathematically. Actually, this is mathematic as well, but in set theory, this is set theory notation, but you can write it in this way, which is much fancier or something. Where let's make this notation. Let's see this fancy notation for the set of algebraic numbers. Okay, so actually this is actually it doesn't matter. So what we're going to do is if q, well, okay, so this is fine. The way it is right now is fine. So we see every rational number is algebraic. So let's say this is a lemma, and let's give a proof for this, and that will be the end of the video. So we just want to show that Q is algebraic. So that's pretty easy. All we need to do is you need to find a polynomial, a rational polynomial, for which Q is the root, and maybe you can try and work out what this is, but it's x minus q is equal to 0. So if you plug q in, you get 0. So q is solution to this polynomial right here. So this is the p that we're looking for, the polynomial p, or p of x if you want, but the polynomial is p, and so q is algebraic. So all rational numbers are algebraic. Next we will show that if a number here is square free, that means it's not something times a square number, right? Then if we square root it, let's say q is square free, then square root of q is algebraic as well. Not only square free. In fact, we'll show it that like literally no matter what rational number you square root, it will be algebraic. So that'll be the next video, and yeah.